Let's look at another example comparing and to or. We have the set of x such that negative 1.5 is less than x is less than 2. This is an implied and statement. It could be read the set of x such that negative 1.5 is less than x and x is less than 2. To graph this, we would need to locate negative 1.5 on the number line. Since it doesn't appear, we can just write it in. A negative 1.5. Can't seem to get that decimal to work. And we want to include an open circle because this is not included. There's no underline in this inequality. And we want to shade where x would be bigger than this number. So we'd be shading to the right. We also want to stop at the number 2. That has an open circle as well because the inequality doesn't have a line under it. So we'll only shade between positive 2 and negative 1.5. Look at another set. X such that negative 1.5 is greater than x or x is less than 2. Again, negative 1.5 doesn't show up on the number line. We can write it in as a negative 1.5. And we would have an open circle for that. And we would be shading to the right for greater numbers. The or statement says graph the union. So I have an open circle at 2, and I want numbers less, not included, so I could shade left. But I shade right through that open circle. In fact, as this arrow continues to the right, I shade right through that open circle. So our graph is, in fact, the entire number line. It is all real numbers. So our or statements can have 2 arrows pointing on the outside, or they could shade everything. Our and statement will be trapped between 2 circles, or it'll be nothing.